the eyes, leaving worries behind. The minutes seem to fade away, stand still at the same time. When we're out here chasing city lights, drunk in love, we lose our minds. It's only you and I, living for these sleepless nights. Today I'm so long away, dancing on tabletops. Oh, we gotta make it count, like tonight, so we got. While we're out here chasing city lights, drunk in love, we lose our minds. And it's only you and I, living for these sleepless nights.
And people.
Sleepless nights.
One.
For these sleepless nights.
Like a desert in the middle of the ocean, you're a feather. You try to hold on to devotion and your treasure. Every square inch of emotion, but you lose your grip. Yeah. Tell me now, are they tears or are they raindrops on your face? Does it look like there's a river full of waves? And I'm sure you know exactly what they say. Thunder only happens when it rains. Thunder only happens when it rains. Like a desert in the middle of the ocean, you're a feather. You try to hold on to devotion and your treasure. Every square inch of emotion, but you lose your grip. Yeah. Tell me now, are they tears or are they raindrops on your face? Cause it looks like there's a river full of waves. And I'm sure you know exactly what they say. Thunder only happens when it's raining.
Strangers in the dark, but
CSS or something. Yes, and there were some nice LaTeX. Yes,
Hey guys, can I have your quick attention? So we will be taking photos during the event. And if you don't want your photo to be taken, I will kindly ask you maybe to sit a bit further away, just for your consideration. We still have monitors there. So it's time to switch if you want now. Gina, we're good to start? Yay. Cool. Hello, everyone. It's a lot of people that I didn't expect this number, but here we are. Amazing. Well, why are we here today? Because we're hosting Düsseldorf Data Science meetup. My name is Aida. If you already do not know me, and I'm one of the co-organizers of the meetup. I joined very recently in February, but we also have some old co-organizers here if you already had the chance to grab them and talk to them. But if not, special shout out to Sijan, Nasiba, Ido, Anne, and Claudia. So what's going to happen today? Today we're going to have three speakers. One will be speaker from Trivago, Alex Fischer. And we also have two presenters from the Stepstone, Michael and Tim. Without further ado, I want to go straight to the presentation, but just a few rules because I have to tell them. So it hasn't happened in the history of Trivago for 5 years, but just in case of a fire, we have elevators in the back. So please don't use, stairs in the back. Please don't use elevator in case of fire. You know the drill. As I already mentioned, we'll be taking some photos. So if you don't want your photo to be taken, maybe it's better to sit in the back. You already know where the kitchen is, where the bathrooms are, just for organizational purpose. Please put all of your bottles and the trash in the crates and the trash bin. And anything? No. I actually have an icebreaker before starting, just for speakers and me to know the audience who is here. So let's play a little game, and then right afterwards, I pass it to Alex. So you just need to raise your hand if you can relate to one of them. So raise your hand if you are working in any data-related field and background. Quite a few. Okay, that's roughly maybe 70, 80%. Okay. Now raise your hand if you're working in engineering-related field. A minority, but still a few people, yeah? Okay. And now raise your hand if you're in none of the background, but you're here because we're going to be talking about salary prediction, and it's a very hot topic. Okay, I expected more engagement, but it's okay. Cool. Then we proceed to our speaker. Alex will be presenting first, 15 minutes, and we will have Q&A.
So, hi. Yes, my name is Alex. I have 50 minutes. Maybe it will be 20. This will be a slide to the force. People have seen my slides, I think. And yeah, let's see if I can make through it. But the title of the talk is Mostly Harmless Data Science Crossed Out Linear Regression with PyFixest. And basically what I'm going to present today is an open source project that I work on in my free time called PyFixest. And what you can do with it, well, you can basically estimate all the linear regression models that you need for all the data science work that you could ever imagine. So basically the pitch is you can do mostly everything with linear regression. That's why the data science is crossed out. So I want to start here with this short video. Maybe you've seen it already, so maybe we could play it. So basically, whatever you do, and so because we're at Trivago, wherever you go, you know what you have to say. Linear regression. Okay. So basically, there's a multitude of applications of a very simple model. It's like a lot of use cases, and I quickly run you through them. Yes, more linear regression. So it's really all you need. And so the other thing is that economists really, really like this. So basically, if you look at an economics journal, you will see nothing else but linear regression, one after the other, after the other, after the other, after the other. It's like there's no basically literature and statistics, there's no data science, it's just this one method. So it's like economists really like it. There's a couple of reasons for it. It's fairly easy to compute. So It's like you don't have to wait for your results for a very long time. So that's usually a problem with fancier machine learning models, also with Bayesian methods. There's a lot of crunch time. These models are usually super interpretable. So you run them, you get a number, you can explain to your business stakeholder what you've actually been doing. So that's kind of cool. They're super flexible. All you need is the keyword here. And they also have a couple of nice statistical properties that I don't want to bore you with now, but overall these these linear regression models do quite well. Now the next thing is I'm an economist, right? So I really like this thing. And I've done a thesis back in university. I worked a lot in a programming language called R. Have you heard of it? Oh, that's interesting because okay, I thought this was mostly industry here, and no one in my team had heard of R. Oh, no, it's actually not true, but yeah. Anyways, so but I have a very hard time selling it. Anyways, there's a magnificent package called Fixit. It's like super, super, super good. And the key selling point, it's like incredibly fast. And it innovates on another front. It's extremely user-friendly. So there's a lot of API features that are extremely nice. And so basically, I thought, okay, it's like at some point someone has to do it and port this over to Python so that all the people in my team can actually benefit. So no, but basically that's it in a nutshell. And the roadmap for today will be basically linear regression and fixest primer. And then I will talk about PyFixest in all its glory. Okay, so basically, because we're going to talk about the wages today, I thought, okay, I'll open up with an example on wages, right? And so later today, people from Stepstone will talk about wage predictions. Here we are in another area. We're kind of in this causal inference land, and we really want to know what is the causal effect of more education on wages. So if you take more years of schoolings, will your wages be higher in the labor market? And it's like, you could argue, well, you learn things, right? That's like you get a degree, and the more schooling you have, the better it is, right? And so how would you kind of prove that? You get a data set. And basically the economists would say you have a data set with wages and with years of schooling, and well, just use OLS, right? Or basically linear regression is kind of synonyms. And then you get a regression model, and that's fairly easy. It's like, I guess your data people, most of you, you've seen this, right? We have wages on the left-hand side, okay? And so basically here we have years of education. And so then we basically estimate that relationship between the two with a linear model. Okay, and so how does it work in Fixest? Basically we can use R's formula syntax, log wage on education. And so then it's super easy, right? It's like a free liner. You have to load the library. You said fixed effect, OLS. OLS is the fitting method. Plug in the formula, plug in the data frame. You're done. And then you get this very nice result here printed out. And wow, it says, okay, 1 more year of education increases your wages by 5%. That's pretty much, that's quite a lot. I'm not sure if this is something that you see in your data, if people plug in, like maybe you can comment on that later. Now, so basically now we've run this regression. Basically, this is the relationship. 1 more year of schooling, 5% higher wages in a given year. That's quite a lot. But yeah, so take a step back. I've seen we have some engineers, so it's like basically explaining. I tried to explain what is a regression. Here's another attempt. So in a nutshell, we fit a relationship between an outcome variable. Here's a log of wage and a variable of interest. So basically, we want to know what's the relationship between these two variables. And we do this by minimizing the mean squared error. And that's basically it. And in some way, you can think of this as curve fitting, right? And basically, you have this relationship here between, well, here's the log of a wage, here's more years of schooling, you have the data points, you fit a linear line between these 2 points. And so basically, the curvature here then will be 0.5% increase. So that's basically it in a nutshell. Not super difficult, but super, super, super useful for a lot of problems. Because basically, this is a figure you can show to, say, your business stakeholders and explain it. So that's cool. But I've argued, okay, we have now this regression model, and 1 more year of schooling leads to 5% higher wages, right? So, okay, but like we're data scientists and we ask the hard questions, right? So is this actually a causal effect? Well, okay, and so what does a causal effect mean? I basically pick you. We do an A/B test, right? We split you into half. Group A gets 1 more year of schooling. Group B gets 0 more years of schooling. Will Group AB have really 5% higher wages or not? Will that really be the case? And so that's not necessarily the case. And here we are moving into somewhat more advanced regression territory. So the key problem is that there's this big unobserved variable, which we could call like ability, or sometimes it's called intelligence. It's a little bit fuzzy. And very likely it is correlated with the number of years you go to school, right? It's like if you finish school, might be correlated with your ability. If you go to university, might be correlated with your ability. If you do a PhD, might be correlated with some latent factor that we haven't measured at all. And so that's correlated with the variable that we want to explain wages with. But then you could also argue that, well, if you're actually super smart, then you're also going to make more money. And so the key question is if that relationship between earnings and education is actually causal or just an artifact of people with higher ability sorting into more years of education. You could even argue, well, maybe education doesn't even have a causal effect on earnings at all, and it's just purely ability that explains all of it. And so that's the key question that the entire field of labor economics is struggling with. And it's like trying to understand, okay, is there really a causal effect of this thing called education, or is it just ability? And so just to explain this plot, I'm not sure how much you're on Twitter. Oh, it's now X. By the way, there was sponsored placement of X Corporation in the regression equation. I'm not sure if you've seen that. But so basically here, what you see is this plot, right? So this relationship between a wage percentile of workers for Swedish workers and basically the intelligence score. And the Swedes, they have this amazing register labor market data, right? They know what you earn for the entire population. People have to go to the draft. So then they do basically ability, aptitude tests. So they have all that data. And so basically you see, okay, if you're smarter, you make more money. But if you're smarter, you're more likely to go to university as well. So, but yeah, so then basically economists have thought about this problem a lot. And at some point in the 20s, and I will jump over this now because I'm running out of time, people have come up with a method called instrumental variables. And so basically, I'll completely jump over it. The key idea is, well, basically, do you find some sort of other variable that mimics random assignment as in an A/B test? And so in the very early days, people started with something called distance to schooling, where basically people would argue, well, maybe in the 30s, how far you lived away from a university was as good as random. And so then how far closely you live to a university would be predictive of you actually attending, because, well, costs would be smaller and it would be almost randomly assigned. And then there's a couple of other arguments. It's like people, this is where the literature started out. Anyways, this is IV. And at the end of the day, it's just 2 regressions, right? So that's a funky thing. And so in Fixest, you can do this super easily. Okay, now I hope I haven't lost you completely. But basically, it's a one-liner again, and you have these results, and wow, it's actually super nice. You can get a plot out of it straight away. Super cool. Yes, some of you I've seen use that plot, and I've used it as well. So that's really nice. Okay. You can do a couple of other things, right? So in regression models, you get this point estimate, and I talk about you get 5% higher earnings if it's causal or not. You want to kind of conduct inference, compute confidence intervals, all these things. You can do a couple of things. And so what's super annoying, if you fit this entire model and then you decide, oh, afterwards, I want to actually have another way of computing my standard errors, right? Do you really have to refit the entire model? It's like in some packages, some regression packages, you actually have to. And that's quite annoying because like you just wait there and have to compute everything again. And it's like here in Fixest, you can just do it on the fly. It's like basically you have this model fit IV. We had one type of standard errors. It would be IID distributed. This is what we do in A/B tests all the time. But here we have some covariates. We want heteroscedastic errors. You can just do it after fitting the model. So that's super convenient. Okay, so it's very nice. And now we come to the secret sauce of the package. It's super, 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 super fast. Okay, and in particular with so-called high-dimensional fixed effects. And so what is that? For example, you would assume like, okay, now maybe we're interested in including a dummy variable for basically the firm that a worker works in 5 minutes. Oh my God. Okay, so we make it 10. Okay, I'm talking very fast already. So basically you have a data set, you know how many years a worker was in school, you know what wages this worker is earning, and you actually know where this worker works, right? And so maybe you would have like 3,000 workers and they work in 500 firms. So you include that in the model. In machine learning terms, that's called one hot encoding, right? You have this categorical variable, like, and so basically all of a sudden you have this super, super, super large feature set, right? Okay, and so this can be quite a big problem. It's like in labor economics, you might have like a data set with not just 3,000 workers, as I was presenting, but with millions of workers. And it's like in Germany, how many firms do we have? I don't know, maybe you guys know, but it should be probably more than 1,000. So it's like, if you include all of these in a regression, like that's all of a sudden becoming a big, big, big problem. And then you might even have a panel data set. So you like have time in there as well. So like all of a sudden you have this like super big one hot encoded matrix. And to estimate the ordinary least squares model, you have to invert it. And that's like super annoying. Basically, your computer will die. If you try to do it in memory, you basically can. Well, you could try to do it in Spark, but even that would be annoying, right? Spark has a lot of limitations in terms of statistic. But it's like actually, Fixest can handle these things quite nicely. And so basically what happens on the hood is, we apply Fixest applies a theorem also from the 10s or 20s called the Frisch-Morgan-Lovell theorem. And so then everything happens super, super fast. Okay, super fast. Here's a benchmark. I'll actually show you the next benchmark. So here we have a regression model, 10 million observations. So basically what we run here in trivago, say we have 50 locales, right? And we want to control for locales in a regression. So like we have random assignment, that's treatment effect. So basically, then we basically use a linear model, LM, that's Bayesian. It's like the same as stats model or less. Okay, it runs for 80 seconds. Like with Fixest, you get the same thing in around 2 seconds. Like it's super, super, super performant. It's extremely cool. Okay, and so that's like 35x. Okay, I jumped over this. Okay. So, but okay. Oh, I have time. Okay, cool. Then I will slow down. Okay, any questions? No. Okay, that joke. Okay, so basically, I've done a pitch, right? So this Fixest thing is really cool. Like, so I claim you can do it. You can use it for all the business problems you have. It's super fast, super efficient, has a couple of user-friendly features, but it's in R. Yes. Okay. So actually, I love R, but yeah, a lot of people actually don't know it. So okay. So the goal is build a Python package with all these API innovations in Python. It's like of Fixest. It should be super easy to use. So basically use all these API innovations and make it fast. But that's for the moment not a prime criterion. But so basically right now the package is not as fast as Fixest, but it's fast enough for most things. Okay, and so basically then implement the most important features of Fixest. So that's OLS, that's IV, there's another thing called Poisson regression that you might want to use if you have count data like clickouts or bookings, or it's like, I'm not sure, signed contracts. I'm not sure if you care about that. So things like that. Probably you only sign one though. Okay. So multiple options to compute standard errors, all the things that you would want to have, multiple estimation functionality. I didn't really show you this, but I'll show it to you later. And so that's the goal. There's 2 key libraries that it builds upon beyond pandas, SciPy, and all these things. It's a PyHDFE for kind of running this, applying this Frisch-Morgan-Lovell theorem to handle fixed effects super efficiently, and a formulaic, which is basically the successor of a Patsy library for handling formulas. Okay, and so let's run a regression in Python. We load some data. It's the same data set. I just send it over from R. And so because we're in Python, right, we have to initiate the class object, right? Because like this is like, we have to do it object oriented. And so basically here, that's what happens, right? We assign the data set to the object. We have the Fixest object. And now we can estimate a model. Basically, there's 2 methods for it. FE-OLS, like in Fixest, just fixed effect OLS, and for Poisson regression. And well, we do it, and we apply the summary method, and we have all the results. And as before, well, as it should be, we get the same results. 1 more year of education leads to 5% higher wages. So that's pretty cool. We can do a couple of other things. We can obviously check if I match results, and I do. And so I make sure of that with some unit tests. So that's good, right? So we have that. Here's actually one of the kind of super cool API innovations of Fixest. You can estimate multiple regression models in one go. And so there's like advanced formula syntax. For example, you have this SW function, you have a cumulative stepwise regression function, and some variations of that. And so what this allows you to do is basically on the left-hand side, now you have two variables. That means that for each of the variables on the left-hand side, estimate a regression model. With specification 1, you have education in there as a control and south. And the other specification would be education and ethnicity. So basically in one formula, you estimate, I think, 4 models here. And it's like basically if you go down, you would see estimation results for all models. But unfortunately, I can't do that because I don't have access to the screen. Anyways, it's super cool. One of the key things of this is that it's very, very efficient computationally because there's a lot of steps that you would have to redo in each model fitting step that you can basically do in one go now. So that's quite neat. So in particular, if you estimate a model with, say, 10 million, say in trivago speak, 10 million sessions, 50 locales, and a couple of other control variables that you would want to throw in. So you gain a lot in time. Okay. Standard errors, you can adjust on the fly. Everything is like, okay, comments we want for implemented. So that's quite neat. They also match Fixest, and that was quite a lot of work for some reasons. I want to go into, you can estimate AV models. Basically, the API is exactly the same, right? You have a log weight, you have an instrument, you have a variable that you want to instrument for, and basically it's exactly the same thing. And you just move along, you get the same results. So that's implemented. One more regression model, Poisson, you also have that. Just a slight variation. It's kind of the class of generalized linear models. At the end of the day, it's also just weighted regression via this iterated, reweighted least square algorithm. So you have that. You can estimate the regression with Poisson and potential high dimensional fixed effects. It's actually quite fast. So it's cool. So okay. No rush through this. Next steps. Okay, here's the second kind of meme of the talk. Woo. Okay, so from the outside, from the inside, right? So okay, it's very nice and shiny and kind of like you can use it. I have all these nice examples. It's quite pretty, but basically it's kind of the first larger Python project I work in. So inside it's can be cleaned up a little bit. So yeah, but it's open source, so you can actually take a look at it and yeah, give feedback. That would be amazing. Beyond that, yeah, well, code cleanup. So here's the other thing from smelly to flowery. Okay. There's a couple of things that are not implemented, weighted least squares, like standard things like F-tests, IV diagnostics, prettier plots. Yes, okay. It's like, okay. It's like two-way clustered standard errors and a lot of other things. Okay, blah, 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 blah. Okay. Yes, one important thing is like, okay, I'm searching for collaborators. So if you want to help me with that, please talk to me. That would be super awesome. Okay, thanks a lot for your patience, for the time. That was it.
Thank you, Alex, for a very nice talk. And sorry for rushing you through time. Anyone has questions for Alex?
Thanks, Greta. Thanks for the talk, Alex. Very interesting package. We could talk a lot about linear regression and how it doesn't work every time, but about your package. So two questions. So first of all, why do you think plotting should be in the package? Like
Oh, it's just convenient, right? It's like you have fitted a model, you want to look at it visually. You just plot it. It's like Fixit does it. It's super great.
Maybe it would be better to make it easier to use plotting packages that are plain in Python. And the second question is the formulas that you put in, right? You define it as a string, and it means that every typo there is crucial.
Yep.
Didn't you think how maybe you can make sure that inputs in the string would have some relations to what was in the data set?
So basically, this is what this formulaic package does for me, right? So basically, it kind of translates a formula expression that is a string into a data matrix, right? So basically, a model matrix is how it's called. Now, so this is handled. The package is very, very good. So I'm not too worried about it. But I introduce a couple of kind of these syntax sugar features. And it's like there are some things that could go wrong because I do string deparsing, and if I do that incorrectly, there would be an error. But yeah, I've so if you feed in like very weird things, things might go south. But in general, it's checked. Yep.
Thanks for the presentation. So does the package tell you if your model is like underfitting or overfitting?
No. No, it does not.
Okay.
Yes.
Is that something you might want to think about adding? Like, for
Uh,
example, someone like me who's like never actually created a model, like I wouldn't know if it's good. So I feel like that could be a good step. And then maybe on top of that, suggestions for techniques on how to reduce one of those things.
So basically this overfitting, underfitting is kind of a question for more of a kind of ML prediction kind of use case. And so actually that's not the use case.
Oh, fair enough. Okay. See,
So that's one.
I don't know enough
Yeah.
about data science, so thanks for clearing that up.
But I sold it to you. You can do anything. So, well, I mean, you can make predictions, right? There's a predict method in there. So you can, but yeah, there's no full feature.
Any more questions in the room?
Yes, thank you for your presentation. In this whole process, did you also had any contact with original people that made fixits of R, and how was actually their source code? If you
How was what?
The original source code. So how did you find, like, you transferred it, or
No. This is all pure rewrite.
okay, you didn't look
So,
at the original source code
not really. It's like most methods are kind of straightforward to implement. Some algorithms are published in research papers. Basically took that. Then of course I looked at the API and the documentation and kind of standard behavior, and for that I looked at the source code. Yeah.
Okay, cool.
Yeah. By the way, it's like this kind of, I think the talk I promised to that I would comment on Chat GTP and Copilot, how to use that. I actually got a question if I managed to translate all the R code into Python. And yes, I did not even try. I don't think that would be possible for a package with, yeah, I don't know, 80,000 lines.
Any more last questions?
Yeah, so maybe about the geeky part, but so this theorem for quick converting matrix. Could you tell more about it?
So it's not for quickly inverting matrices, but so in principle, it's about demeaning data in a specific way, and then you can run a regression on the mean data and will get exactly the results as you would on not the mean data. So basically, you sweep out all these fixed effects, and thereby can you reduce dimensionality of the problem by a lot. Yeah, it's a little funky, but that's kind of the workhorse of it's like every single published paper in economics in the last 10, 15 years. Yeah.
There are no more questions. Thank you again, Alex. I think it's fair to give people 2-minute break in case they want to use elevators, grab something quickly, and in 2 minutes we're here.
Yeah, actually.
Okay.
Shall we go? Thirty seconds.
That's nice. I think. Oh, go good. No worries. So, yeah, you can.
Should I stand the whole time? No, right? I will just chill. Yeah, sure.
Okay, guys, let's now proceed with the second presentation. Thank you very much for coming here from Stepstone all the way to present a very interesting topic. Yeah, without further ado.
So thank you, Ada. Thanks also to everyone from trivago for hosting us and for everyone else who joining this talk. So if you don't know what Stepstone is, that's kind of the corporate slide that I had to put in there. So we help companies hire the right talent. We're a job board, but we also do many more things. And that's what we're talking about. Like one of the particular things that we need as a job board, salary. So I'm Michael. This is
Hi, I'm Tim.
This is Tim. So we're presenting this. So we are the ones holding their faces into the camera today. But this is actually, of course, a team effort with a huge data science team behind it and a lot of people that contributed to this. But today we are the ones that actually get to talk about it. So one more slide from corporate and then I'm done. So we have around 150,000 enterprise customers, SMB and enterprise customers. So that answers the previous questions about how many companies there are. And not all of the companies in Germany are actually our clients. You wish, but they're not. So, and we have like a billion euros in revenue. So I don't know why that's relevant, but I was supposed to tell that. And we have around 4,000 employees. So if you want to learn more, we are like literally a 5-minute walk from here. So check us out. So, but let's now talk about more interesting things. For instance, salary. So what's the situation in the German job market? So essentially everyone cares about salary, right? So there was a survey done a couple of years ago. What are the most important criteria when looking for a job? Unsurprisingly, almost everyone said salary, and then the other things with a huge gap in between. So it's one of the most requested features from candidates when they're looking for a job.
And obviously, it's also one of the most crucial things when matching people with jobs, right? So if you get a recommendation that is way below your salary expectations, you don't even care about reading the listing because it doesn't fit for you, right? So what did we decide to do? Well, we had to build a salary product around it because it's so important. So what we have is the salary planner. So essentially, when you go to StepStone, you can go and fill in this questionnaire where you answer questions about your employment status, about your current salary. That's actually how we get the data that we need for our models. So it's mandatory to fill it out. We ask about your current employer, your industry, how many employees this has. Actually, I'm kind of embarrassed because this is not current anymore. We recently updated this to also ask for the name of your employer, which we didn't do before. But yeah, so we should, and now we do, and we will also use it in the models going forward, not yet. Then we talk about your work experience. We talk about whether you have leadership responsibility, budget responsibility, and also previous question, does education correlate with salary? Yes, that's why we ask for your degree. And that's why we ask for your field of study, for instance, right? And then what you get in the end is a salary prediction for the parameters you entered, right? So we can give you basically an estimate based on the data points, and then you can say you're actually below or above the median, and that's something that you can either go into salary negotiations with or apply for a different job, or just feel good about yourself because you have good salary, right? So, and the products that we run with this, as I mentioned before, the planner, which is already live in several countries, and we have thousands of daily users. So it's a constant stream of up-to-date salary data for training new models. We have salary information on listings. Some people already asked about this. So it was one of the biggest and most controversial changes because clients didn't really like it to show salaries on listings, but it drove all of the metrics up. So business-wise, it was a great success. We have auto-generated salary SEO pages. So if you Google for data scientist salaries in Düsseldorf, we have pages that are based on our model that are just generated, and you can basically drive traffic to StepStone. And we have many more in progress. So this is basically the B2C side for job seekers. We also have B2B products. If you're interested in that, for instance, if you're working in HR, there might be something we have for you as well. And this is essentially a significant source of traffic for and registrations for StepStone. So all in all, very interesting product. So some of the challenges that we had, or that we still have, is of course data distribution. So we have overwhelmingly more white collar jobs. That's due to the nature of StepStone, or due to the nature StepStone is perceived. Unfortunately, we have very little data on part-time jobs. So this is something that we're actively working on, and we all rolled out recently also for listings that we have predictions for part-time salaries. But this is something that we are still a bit struggling with. And of course, some salary bands, especially higher salary bands, have poor representation, right? So you only gather so much data about CEO salaries or head of salaries, because yeah, it's also kind of a random thing. So if a CEO gets 200,000 or 300,000, so we're struggling with this. And of course, always the elephant in the room when you talk about salaries, the gender pay gap. So the gender ratio is also imbalanced. So we have more men than women who answer these questionnaires. And right now, at the moment, we don't use gender at all, because we can't have a product that's user-facing where you change the gender and the salary goes down or up, right? So this is just not something that we can do. We are looking at ways to analyze the salary. So we compute the gender pay gap, we report it in our salary report and so on, but we're not using it for the modeling. But we're looking into ways of making this more transparent, but this is still work in progress and not something that I can tell you right now. So now that I've talked a bit about the business and product side, I want to talk a little bit about the data science side as well, because it's a data science meetup. So this is like the general overview about the steps. And what we're actually doing is several steps. So first of all, QA. So we filter the data that we gather to the planner based on the market or the use case. So we have several markets. We have several different use cases, as you've seen, some logical rules. We do some outlier detection. And this is what it looks like, right? So for instance, we filter out salaries where the age and experience doesn't match, right? So if you're 20 and you have 10 years of work experience, not really. So, and some other things that don't make sense. And then we end up with a cleaned up data set. Then we do some feature engineering based on the features that you saw. So the questions that we have in the questionnaire are basically the input for a feature. So some categorical, one had encoded numerical, depending on what they look like. Plus, we also use dense vector representations, also known as word embeddings, to enrich our model. So essentially, it's a BERT model. If you're familiar with that, it's trained on our own listing. So essentially we have a vector representation of listing texts that we can use to enrich these predictions. Plus, we also have a secret sauce. So it's not only you, but we also have a secret sauce. We have a linguistic ontology. That's essentially a handcrafted resource of over 250,000 jobs that our linguistic services team is building at StepStone. So what you essentially have is a huge connected graph that describes all of these jobs in detail, their relationship to each other. You have the discipline and subdiscipline. So you can also use this information about which jobs are related to each other, which jobs are really close to each other, like Java engineer, Python engineer are subclasses of software engineer, for instance. And we also use that information to make this model a bit more robust. So, and what's the model under the hood? Not linear regression. Sorry to disappoint. We are also familiar with that, but we're actually using LightGBM, which is a tree-based model and one of the best algorithms for solving this kind of estimation mod problem. So we know it has some disadvantages over linear regression. It's not as interpretable or not as easily, like, let's say, manipulatable. But yeah, from the result side, and that's really what we care about, it's still one of the best. And yeah, this is what it looks like. So we also have to have some code in there. How you configure it. This is essentially for the hyperparameter tuning, where you set the parameters of the algorithm. So like the number of leaves in the tree and so on. So this is what it looks like when we automatically tune the model. So one more thing about the quality. So the main business KPI that we're optimizing for is the median proportional error. So essentially how many data points in a test set are below or above the median. So roughly it's 12% on DE. So the median error means that, okay, we're doing good for a large portion of the data sets or data points. But there's also, of course, the other side, as I said before, with the higher salary bands or jobs that have a very low representation data where it's not really good. But yeah, we're constantly working on that set. And the other thing that I want to mention is generalization. We also had a question about overfitting earlier in the audience. So what's important for us is as well that the feature importance is evenly distributed. So what does it mean? So if you have a decision tree like LightGBM, you use the features to split the tree in certain positions. And what this expresses is essentially how often a feature is used for splitting the tree, right? So, and if you look at this is actually a good distribution, because you see the model is actually learning information from, okay, does this work? I don't know. From like the 4 or 5 topmost features. So it's relatively robust, right? But if you look at this distribution, for instance, it's not as good, even though the accuracy might be good, but you see that it heavily relies on the first feature and the other features not used so much. And this means if the model encounters unseen data or a new combination of features, it doesn't really fit to that. So this is something that we try to keep an eye on, that the model also generalizes well over unseen data. And the good model has both the high accuracy and a high generalization capacity. So this is what we're aiming for. So this was the data science part. So if you have more questions, we can ask them later. And now actually I'll hand over to Tim for the engineering part. So
yeah, thank you, Michael. So I'm a machine learning engineer. So I hope, even though this is a data science meetup, that can also be interested for everyone. So I joined StepStone 2 years, and the project was already there. So there were already salary estimations on StepStone. And it was working as following. So you had experimentations to look, okay, what kind of data do we need to filter in order to have representative data? And you can do that in a notebook, you can do it wherever you want. And then we had this SageMaker job. So that is a part of Amazon AWS, where you can easily have some code that you build, but then deploy it in the cloud. So you don't have to crush all those like 100,000 of entries on your local machine. And then it ends up, after this filtering job, it ends up in an S3 bucket. So that's just storage. Then based on the data scientist can train a model. But in order to do that, you have to iterate a lot. So you can change some features, you can change some hyperparameters. You can experiment a little bit in Notebook, but once you think, okay, this should work on the whole data set, you can again use SageMaker. You just plug in what you did in experiment and run it in the cloud. And the end product of that is a model. Then you have a model, and then you also want to make sure that our clients or internal products can use it, so you can deploy it with, again, a SageMaker endpoint. So SageMaker can just be replaced with just a container in the cloud. And again, the data scientist can talk to that model. Okay, does it actually give accurate predictions? Does it make sense before it actually goes live? And as Michael mentioned, there are multiple models that we are training for different use cases, for different markets. So this process needs to be done multiple times, and also different moments in time. You can imagine that if I now give you a prediction for your salary, that prediction might not really be relevant if I ask it the same next year. So because we continuously get new data, or machine learning models also continuously need to be updated. So this pipeline we are doing multiple times a year. And because also we have a lot of different models, this is just a lot of work. But you already see that there's some kind of pattern, and we can maybe just package this in some kind of pipeline, in some kind of automated way. And that's exactly what we did. So we have a way that we can just start with some data, and then we end with the model. And how we are doing that is that every day we have a process in AWS Event Bridge that is checking, hey, do we need to update a model? Is there a model that is not updated for, let's say, a month? If so, then we will trigger this SageMaker pipeline, what we just showed. So it will filter all the data, and then in the end of it, there will be a model. Everything what we do with experiments, we log in MLflow. So what we are actually doing is all our metrics are being logged there. We have hyperparameter tuning jobs, so we actually run like 50 different jobs, and then we choose the best one. And how that is then working, we have in MLflow all our data. Or Lambda is saying, hey, there's a new model, and we get a notification in Slack. Hey, there's a new model. Do you want to maybe deploy this in production? This is a Slack message, but also a message that we get in Git as a pull request. So one of our data scientists is getting a message. Hey, we have from our bot, we have a new model. The current model has this performance. Our new model has this performance. Do you maybe want to look into MLflow to see maybe some other specifications? And if we like it, we approve it, we merge it, and then there's a job trigger there that actually the model is being deployed into production or other stage. So we have like also development, production, but yeah. So this is the way how we are deploying models. But we also have different patterns for the different use cases that we have about how to make it scalable. Because we have different use cases, there's also different kind of architectures that we are using in order to handle all the traffic and to make it also cost effective and scalable. And one of the ways that we do that is, this is for our listing model. So sometimes there are randomly new listings being published and they need new salaries, but also sometimes it is being in batches. And in both ways, we need to make sure that every time there are new salaries. So we monitor this in Grafana. And how we do this is we get an event bus. So we get new listings IDs. Every time there's a new listing, it goes to our application, and our application is gathering all the different information. So we get just a listing ID from our internal system, and then we ask different APIs within Stepstone. Okay, but from which company is this listing? Of which job title does it really have? And all the different features. And if we have all the features, then we also ask SageMaker, the SageMaker endpoint, okay, what's then actually the prediction? Once we have the prediction, then we are putting that live on the listing. And this is scaling vertically or horizontally. So what's happening actually is if we have a lot of traffic, new machines are being started, and when we don't have any messages in our queue, it will scale down. So this will make sure that we never have more machines than we actually need here. And we also have a different use case. So actually on our website, if people are asking, hey, what's my salary? Then we already have the right features, so we don't really need all this extra information that we need for the listing use case. And it's also a little bit more predictable. So we just see over the days, like in the night, who is going to go to stepstone.com and ask what's my ideal salary. So it's more predictable, and that's also why we can kind of plan when we have to schedule our resources. And here we use serverless architecture. So people are filling in the salary planner. Then there's a Lambda. So this is some kind of serverless container that is just invoking our SageMaker endpoint. And at that moment, we just show the salary immediately on our website. And this is just scaling without any problems. Another thing we do, so after we are deploying models, we also have some kind of step that our data scientists or other stakeholders can actually consume our models before they actually go in production. So you can really easily create an app with Gradio or Streamlit or whatever program you want to do it. You can create a server or some kind of Lambda function, and you can expose this to your internal network. And we have an URL that says, for example, a salary explainer .internal.stepstone.com or whatever. And here we have a tool that you can fill in information about the listing, and you can actually see what will end up on the website for that specific listing, and also a little bit more information, such as here the Shapley value. So we can see, okay, well, for this listing, it is high because in Frankfurt, they are paying a lot of salary. More than average. So this kind of things we are having for multiple products within Stepstone. Also for prototyping. So before actually we go to production, we usually create this kind of applications. So internally we can test it before we actually show it externally. And this can be really ugly. Like nothing fancy needs to be happening, but it's a way to expose your models, which are most of the time complicated, to your internal, for example, product people. Yeah, that was it. Do you want to say something, Michael? End it?
Well, I think, we touched on some of the points also in your tab. So if you go one slide back, so that's actually one of the things that I wanted to mention. I had it on a backup slide, but we talked about the explainability or like the interpretability. So this is like how close we get to this, that we have these Shapley values that you can actually see how much influence on the result each of the individual features has, right? So all of this, what is here, DE-NEN model is the vectors, so the vector space representation that we have. But you see, we have some very good interpretable features, as Tim mentioned. If you work in a certain city or for a certain industry, or if you're responsible for employees or not, all of these factors, you can directly see how much influence they have on your salary. And you can also see the education somewhere here. So I guess, not in this particular example, but so all of these things are very interpretable. This is also kind of the way we do bug fixing in terms of the model, that we say, okay, we get a specific listing or a specific example from our clients that they say, oh, this doesn't look right, really. And then we can point out to them, yeah, but your company is in a shit location, or sometimes it's just like, well, all looks good and it's really correct, and you're just paying bad salaries. I'm sorry to tell you that. So,
and it's also for explainability. For sometimes the clients are filling in their listings and they say, well, for this job you don't need any experience, and then it's some kind of staff engineer, Java developer, and then for like some of the features are actually looking also at what the client is filling in, such as the experience level. And if that's really low, yeah, of course you get also lower salary. So then it's also some kind of quality control. Hey, you filled in this field wrong, and it also will help them in being findable in the search results.
Yeah, so I think that's what we had to say. So I think we're opening up the floor
Yep.
to
Thank you.
questions.
One mic for the. Cool. Thank you so much, guys. Questions I already see here.
Hi. So my question is more on there are different people calling the same job with different titles in different companies. Like you mentioned, what could be a business analyst in one company could be a data analyst in another. How do you identify if it's like the same job profile and create average salaries or something like that?
So this is what I mentioned before with the ontology that we have. So we have this concept idea, which basically is a certain job with certain criteria, certain skills you need to have, certain tasks you perform. And we also have synonyms for this, which are manually edited and encoded, and also translations for this. So if it's really the same job in terms of you're doing the same thing and you need the same skills, then we try to model this in terms of these synonyms. If it's very closely related, as I said, with like Java engineer versus Python engineer, we do this over this hierarchy thing where you say, okay, you don't have as much data for the one thing, but maybe you have enough for the other so that the model is kind of robust. But of course, something slips through the cracks. So new jobs come up all the time, but that's also why we have this linguistic services team that essentially updates this all the time and tries to stay ahead of the job market. So they also have monitoring for searches, monitoring for job listings that come in and say, okay, if there's a job title that we haven't seen before that is becoming relevant, we have to readjust and change the ontology. And that's why it's always up to date, because we really try to stay ahead of this.
Thanks.
Yeah, my question maybe is a bit of a follow-up. Do you have minimum requirements for the listing in the sense that you require at least a certain number of information entries to be given? And if not, if there are penalties for those cases?
Yeah, yes. So actually, it's funny because we're also working on a product which is called listing QA. So there are a lot of criteria that a listing needs to fulfill to actually be able to be published on Stepstone. So it has to be a job title that is correct. So that's also what we're matching with the ontology. It has to contain information about location, required experience, and so on. Basically all of these features that we've seen before, this is all categories that need to be filled. And there is a filtering process that listings that don't have certain sections, certain information will just be given back to the client, so they have to readjust it. So we have a process that is very convoluted and very complex and not super automated yet, but we're working on it to really make sure that all of the listings that end up on our site are up to the quality standards, which is not always the case right now. But because we also have different sources of listings, we have like self-serving service listings that the clients create themselves. We have listings for our premium clients that we basically help them create. We have a service which is called Stepstone Recruit that essentially automatically generates listings based on your criteria. It's actually very cool. It's also based on the work of another data science team at Stepstone that uses large language models to just say, okay, I need a listing for this kind of job, and they create a listing text for you. So this is like a really cool thing that another team is working on. But yeah, we have to make sure that all of these listings fulfill the same criteria, that they're always complete and understandable and all of these things. And then we can work with these listings on our models.
Thanks.
Hi, I'm interested in your linguistic part, the ontology that you created. Do you have a team consisting of linguists, computational linguists? How does it work? Like the competences of linguists are purely, like language, or is it more on both sides that they can also program a little bit? Because I know that the computational linguistics is also kind of, overlapping there. And I'm just curious how it works.
Yeah, actually, I have to say at this point, I'm actually by training a computational linguist. So I've done all of this stuff before. So I've worked on ontologies. So we actually have both. So we have pure linguists in the team that really come from the side of analyzing it on a really linguistic level about inflections and all of these things that you can use or different formulations of things. But of course, you need to have some technical affinity and some programming skills if you really want to work efficiently in this environment. So actually, I think most of the linguists are now computational linguists, and they're also dipping their feet into machine learning and into using other things that helps them work more efficiently. We're also collaborating with our linguistics team, for instance, on automatically generating synonyms using large language models. This is one of the things that we're doing to essentially just speed up the work and take the workload that is manual and a bit monotonous away from them and let them focus on more interesting modeling tasks. But yeah, so we have a space and we have lots of love for our linguists because they really make sure that we're doing the right thing.
So as a linguist, I could come to you and say, hi, I want to learn a bit more about computational stuff. Is possible as well.
You can come to us. So I don't know if they have job openings right now, but I can check. So if that's what you were getting at, I don't know.
You never know.
Hi, I have more technical questions in terms of compensation. So your data source, from what I understand, is people who voluntarily input this information according to the best of their knowledge. And then you also have some clients who share this information with you? Or how are you collecting your data?
Yeah, so our main source of data is actually the salary planner. So the people that give away their salary. And as I said, we try to filter it, try to make sure it makes sense. But in the end, it's a good faith assumption that the salaries are correct, right? So no matter how much filtering or outlier detection you do, you have to assume that this is the current market situation for this particular job or this particular constellation. So that's what we're using because it's the best we have. We also have the salary on listings product, as you mentioned, and some of the clients are actually giving us their salary. So we actually know what the real salary is. And we were like super hyped about it that, okay, now we can actually train on real salary data. No, because it's only like 5% of the clients that actually do this right now, and it's not representative at all. So that's one problem that we have in DE, that clients are super, super cautious and super anxious about sharing salaries. It's a bit different though, for instance, in the UK. So one thing or one change that recently implemented is that in the UK, actually 70, 80, I don't know the exact number, percent of listings carry the real salary given by the employer. So we switched there from not using our salary planner or not exclusively using our salary planner data, but actually using the data that is provided by employers. And that worked really well because the salaries are much, much more in line with the expectations from the clients. And they're also, the error rate is a lot lower. But this is something that unfortunately we cannot really do yet in Germany. But yeah.
Okay, maybe then I have a business proposition later on. But you can source reliable data even in Germany.
I know we can. So we know that there are other sources of data, especially for training the first version of the model. When you didn't have the salary planner, we did buy data and gathered from different sources. I know there are, but there are different caveats and things that don't really make this a good solution for us. So in terms of how current the data is, if the data representation is really what we're looking for, if all of the job titles that we're interested in are actually in the data. So instance, if you look at data from Arbeitsagentur, like the Federal Office of, I don't know what the English term actually is, you see that it's really outdated, right? So some of the data sets that we used for a couple of years ago, they didn't even have data scientist salaries. They didn't even know what a data scientist was. So there's always something that you can take from that, but it's not really representative or complete in a way that would make it really useful for us, unfortunately. So.
But yeah, I mean, as trivago, we do actually purchase this data and then we do run our analysis. It's more reliable than somebody who's inputting the salary. So, and job matching is also taken care, like in terms of job matching, in terms of career levels and titles, all of that. So probably that's a more reliable source.
Yeah, I mean, as I said, we looked into different sources. If you have one that we haven't looked at before, we're always happy to learn more about it.
All right.
Okay, I go first to Alex and then I come to this one.
So yeah, I was actually also curious about measurement error, but you covered that already. So what I'm wondering now, you mentioned that now in the UK, you started showing actual salary that you get from well, basically partner companies. How did you C-test this? Or it's called C-test in trivago. I think you say A/B test. Did you test it? Or was it just roll out? Because I can imagine a couple of difficulties there. Do you know this?
Well, I mean, so we usually A/B test all the things, but this particular change we didn't. So yeah, well, I mean, essentially because UK is also a special market for us because we don't gather as much data. So we already knew that the model for UK was not the same quality as we have for DE, for instance. And for this case, just by having the in vitro analysis basically on the data or trying to look at the different data sources, we saw that the quality of the model is already much, much better, and that the prediction error is much, much lower. So it was actually a no-brainer. We were thinking about A/B testing it for a second, but then product said, okay, if it's so much better, just roll it out. And yeah, we never looked back. It's looking a lot better now. So, but yeah, usually we are strictly A/B testing all of the things. But sometimes if you just see that something is clearly better than the other thing, you don't really bother.
I think continuing on from the topic of using different data sets, and let's just make this question purely hypothetical, so no stress, no pressure. If you are in a situation where you can use multiple data sets of varying quality and of varying prior or let's say initial accuracy, how would you incorporate all these different data sets into a single model? Like, what would be a sensible strategy, your strategy? Like, how would you do that?
Well, I mean, we actually did that. So I'm not sure if you were aware, at one point in the past, we acquired a company called Gehalt.de, like salary.de, whatever. And we basically obtained all of their data, which was in a completely different format, which had a completely different history and so on. It was a huge project in itself to essentially do the feature mapping. Right. So what we did was we analyzed this data, like how can we map the feature space that they had into our feature space that we need for our models? How can we apply same or comparable filtering rules for all of that? So essentially, it was a separate data integration product to make sure that the data that we obtain from the outside doesn't really pollute the model or change the model behavior in a way that's unpredictable. But in essence, it's hard, right? So because their data was also a lot more complex, I have to admit, because they had like 40 or so questions in their or features in their questionnaire, and we only had like the couple of dozen or so that you see. So we actually had to filter or had to extrapolate for some of the things that they had in their data, and in the end it worked. So we could integrate it, but it's something that you don't do in a couple of days. So it's really a major feature engineering and mapping task.
And what about the importance of your individual outputs? So feature engineering, that makes sense. What about the significance of your targets?
So I don't really understand what you're getting at. So
are you treating your translated data like with the other data that you're collecting?
So once the data is actually properly mapped, we treat it the same as our own data. So okay, that's what you meant. Yeah. So once we are sure that it's on the same quality level, it has the same feature representation and so on, we don't distinguish between the two data sources because that also wouldn't make sense. So at this point to say, okay, we trust this data source or this data source more because from our perspective, they're both reliable sources, but they're just differently modeled.
Hello. You said that your first source for the salary calculation is the input that users that go to your salary calculator use, right?
Yeah.
Are you taking into account the possible what's the name? Mapping bias or collection bias in your data? And if so, how are you doing that?
Well, I mean, as I said before, we know that the data is biased. So we know that we have more IT jobs than average. We have more men than average in job market and all of these things. So we don't on that level. So we do some filtering, we do some normalization, as I said before, but we're not explicitly trying to resample the data, for example. So this is something that we could do or that we also looked into, but it didn't really help us a lot in gaining better predictions. So
I'm thinking more that I would expect that somebody that is super happy with their salary, they are not going to go to the tool, and somebody that feels that they are not earning enough money, then they will go. So I can imagine.
Well, I mean, so we have one question in the salary planner that actually asks if you are happy with your salary. So this is also one thing that you can use. But yeah, so you're right. It was a little bit of a black box initially. Like, why are people actually using the salary planner? So, and this is actually something that we're doing actively user research on right now, and trying to ask, what is it actually you're trying to achieve? Are you looking for a new job? Do you just want to know what your current market value is, or actually something else? So we're trying to better understand what the users actually want or what they expect from the product. And then we can also better understand what kind of bias might be introduced by that, right? So if somebody says, okay, I'm looking for a new job because I think my salary is crap, maybe we have to treat it a bit differently than someone who just says, okay, I'm just curious, right? But this is something that we want to find out, and we are actively working on that together with our product management to, get better insights into how the product is used and what the user motivation actually is.
Thank you.
Hi, thank you. I really enjoyed the presentation.
Thank you.
I do have a question for both Michael and Tim. First one is about the outliers. Who define the outliers? Let me redefine the question. For example, the companies based on, I don't know, Silicon Valley has a different range of salaries, and with the same experience, same education, or same fields, the other companies might have a different salaries, right? So how do you define these as outliers to filter out so that you will have the best one? The first question. The second one is for the engineering. You mentioned that you are getting lots of requests from the new users to identify their own salaries. Is it possible to use online training based on these new data you accumulated every day? So it's happening using your framework in SageMaker, or is it not possible at the moment? Thank you.
Yeah, so about the outlier detection, I only glossed over it a little bit. So we're doing this on the JD level, which is the job title. Essentially see what's the distribution of salaries within this particular subset for certain jobs, and then see how much it actually deviates from median. So, right, so it's on JD level because we know that some jobs like, I don't know, consultant, they have very broad ranges, right? You can be a consultant and earn 50K or earn 150K. So this is accounted for, and you have jobs which are very low range or small range. So this is essentially what we're doing. So it's not rocket science. It's basically trying to see how much the deviation is, and then we filter out those entries that seem too far off or that are not logical. But for the thing that you mentioned about the location and so on, and the industry, this is actually covered. So this is what LightGBM covers really nicely, that it really is robust in terms of using these features. So you know that Munich is more pays better salaries than Magdeburg across all jobs. So even if you don't have a lot of information about jobs in Magdeburg, you can still generalize over that because you know that the salary levels in general are lower. And that's also affecting, of course, what a reasonable salary would be in that location. So I hope that answers your question. And now.
Yeah, I think so. You're asking about online learning, right? I think that is should be possible, but I'm not really sure if LightGBM is implemented that, but I don't think the use case makes that much sense, because one individual salary that we get is not really making that much impact in the next prediction. And I think that's what you try to get with this online learning. And also the retraining of it is relatively cheap. So we can just collect new data and just start this training job from scratch. So that's why we don't do that.
Me again. You mentioned before that you are every once in a while you are retraining the model. You are sending everything in MLflow, and then you are deciding whether to deploy or not with a PR.
Yeah.
And how do you decide, whether to deploy or not? There is a human intervention that decides, does an analysis, and say, okay, this is good enough.
So in theory, what we can do is just look at the hyperparameter tuning job. So we just get the one with the lowest error rate and we deploy that automatically. But we have this human in the loop because we want to also check for other things such as the feature importance that we are incorporating. And this is something we can look manually, and we can in that moment decide, okay, maybe we don't want to have the one with the lowest error rate, but there's one a little bit higher error rate, but also has some other advantages. Maybe the model size is smaller, like maybe because the depth of the model that it finds the optimum in is smaller, like different kind of ways, but yeah.
Okay, thank you.
Thank you for the presentation, and pardon my voice. I have two questions. So first one is more general. Do you see any anomalies in the salary and location relation after the remote working opportunities, or do you have such recent challenges?
So you mean what kind of fluctuations? I mean, we always see fluctuations in the data. So we always see market trend. or
Yeah, once we start working remotely, like especially on the location. So is it a challenge right now or?
so this is something that we actually started working on because so initially when we were working on this, remote jobs didn't play any role. So it was like a very tiny fraction of jobs, but this is getting higher and higher. So we observed this in the data, and but only recently we also started explicitly modeling this as a feature. So right now we don't really see a lot of variance. So because many employers that have a hybrid model, for instance, it does say, okay, we pay according to the office that you're actually assigned to, right? And this is also the case for companies that work remotely. So actually, we work remotely, although we're based in Düsseldorf, and we just say, and we're just assigned to this office, so we get the Düsseldorf salary. And for other companies, there are cases, of course, that you just pay the salary independent of the location, right? So you say, okay, no matter if you sit in Silicon Valley or somewhere in a small village, you get the same salary. But this is really not something we have actively seen or made any thoughts about, because it is not really something that we observed a lot. But I think it will become more crucial in the future to also think about and rethink the way that we use location, because in some instances, location might actually not matter anymore. Or if it's just a full remote job, then the location might be handled differently, but we're not doing that right now.
Thank you. And I have one more question, sorry. So do you also use knowledge graphs? I saw that like you mentioned about word embeddings and so on. And I wonder, like, when you are comparing listing to another, like, what do you consider? Like, how do you compare listing to another listing?
So what you've seen, so actually, do we have the clickety thing? So maybe I can go back to that slide where you can see this. Done. There. So what we actually put into the model is what you see here and what I said before. So we have the concept ID, which is essentially the concept of the job, what I also explained earlier in the earlier question. We have the discipline, which is actually already grouping jobs into certain categories like IT, marketing, whatever. And then we have the sub-disciplines, which are a very fine-grained distinction between the different subtypes of jobs we have. And this is actually what we put in the model. So we know for data scientists, it belongs to a certain discipline, but then you also have this distinction with hundreds of different facets that actually lets you relate jobs. So it could be this different concept, but the discipline and sub-discipline are the same because they're super closely related. And this is actually what we can use to extrapolate salaries for job titles that we don't see so often in data. So this is the explicit knowledge modeling that we use. And the other thing that I mentioned is the word embeddings that are actually used for cases where not the job title or the concept is very similar, but just the listings, the actual description of the job, the textual description of the job is very similar. So this is what goes into it to basically capture both of these dimensions in similarity.
We have 2 more questions. Maybe after that we can take it a bit more informal with pizza and drinks.
I have 2 questions. Well, very fast for engineering part. So how many inferences do you have to do daily, and what's inference time for one prediction?
It's hundreds of milliseconds, under a second. So it kind of depends. So we have this lambda in front of it to make it scalable, and this has like a cold start. It can have a cold start, but if it doesn't, it's like I don't know, 300 milliseconds. And I think we have. Do you know the number? How many?
Yeah, so the average number per day for new listings that we get is like 3,000 to 4,000 listings that are created every day. But this has to be taken with a grain of salt because you also have instances, as Tim showed with this graph with the huge peaks, you also have instances where a big client like creates hundreds of listings at the same time, or there's like some other technical dependency and the listings are just queued up and you have like all of a sudden 20, 30,000 listings that you want to predict at the same time. So this is why we have to make this scalable, because we are just a small part of a bigger business process of creating these listings. So I can tell you the average number, but at any given point in time, it can be 0 or it can be 30,000. So,
okay, so interesting. And so another question for data science part. I think in your case, you care not only about the average prediction, right? You won't also predict the distribution for a given salary, right? So in this case, you need to think in what's called probabilistic machine learning, right? So something like NGBoost instead of your light GBM. So did you look in this direction? So did you try to model not only the salary itself for a given listing, but also what would be the distribution of the salary?
Yes, so theoretically we did, but yeah, I understand what you're getting at, that you actually don't want to just say, okay, this is the one salary range or this is the one salary, but also look at the distribution or like look at the distribution for different brackets, let's say. But this is something that was suggested, and we would like to look at it. But so far, unfortunately, I have to say there was no real business incentive to do this, because the current product is working well as it is and is well established. But yeah, I know that it might make sense to say, okay, there's like a 95% probability that your salary is within this sub range. But yeah, so far we haven't done it.
But one thing we actually have is that we do also quantile regression. So we always predict a range as well. So we show sometimes one number, but for example, with the salary for listings, we always show like a range, because we know that our predictions have some uncertainty. With quantiles.
So if you look at the planner, you see that you actually have the min and max, and these are just like the 20th and 80th quantile in this case, and the middle value is the median. So I mean, it's a little bit cheating, right? So it's not really, yeah. So but it's basically the business decision to have a range, because it is always a range. So you'll never have the exact salary, and you have to make sure that it's kind of representative. But of course, it would make a lot more sense, or would be a lot more informative to do what you say, and just also have the probability distribution. But then again, this is how the product works, or this is how the product was designed to work, and yeah, we kind of also adapted to that. So it's always it's always a balance between how much information or how much knowledge you can put into this, and how much is actually digestible by the users or by product. So
hi, yeah. So just maybe a question about, I think this is a follow-up related to the model selection part. Apart from the distribution of the important features, what sort of concrete metrics do you use for model selection? So, I mean, how do you say, like, light GBM is better than, I don't know, linear regression or XGBoost?
So the decision about light GBM was essentially made before my time, so I don't know. But at the time, or still, it's one of the best algorithms I said for this kind of problem. And so it was never really questioned, but it was definitely chosen over linear regression in terms of just the prediction quality, in terms of the error rates, and also in terms of the robustness, in terms of how does it actually react to unseen data, how well does it actually transfer the knowledge. And that's actually something that was super important for us. And of course, there are other models and options, but we didn't really look into that because we're kind of happy with the way the model works. And in terms of the quality, as I said, we have only these two criteria, the median proportional error. So does it actually work well on the test data, and the feature distribution score? So does it actually scale well, or does it actually apply well to unseen data?
So it's 8:30 already, and I kind of wanted to give a chance for people who want to leave. I also already, my watch just notified me that I did 10,000 steps, so I think we can take it a bit more informal. Thank you so much to everyone for the presentations, for the questions, for coming and participating. Keep an eye on our meetup page for the next meetup. We have a location till 9 p.m. in case anyone wants to grab pizza and drinks. And I guess I will see you around.
Thank you.
Bye-bye.